Okay. Okay, so welcome to this workshop. Let me first introduce myself. I'm Eleonora Lamaro, and I'm the project manager and dissemination manager of Friendship. And welcome to this workshop that is entitled Solar Energy in Industrial Processes, How to Meet the Expectations of the European Commission. And this workshop is a cooperation between two projects, ASTEP and FRIENDSHIP, that answer to the same call of SINEA and of the European Commission. And the call was about solar energy in industrial processes. So it means that both these projects are engaged in meeting the needs of the industry when it comes to heating and cooling with high temperatures, when it comes to heating, like up to 150 degrees, by means of solar thermal energy. And in both projects, there are industrial sites and also industrial networks that are taken into consideration. And unfortunately, 3 years after the beginning of the projects, most of the solar thermal implementation industrial of the potential of the solar thermal of the implementation of the solar heat in industrial processes is untapped. And that there are many reasons behind that, and we will try to understand why during the workshop. But we can say that industrial processes need very reliable and high-level, high-quality heat for their continuous work, and that creates some challenges that researchers should overcome. And so the agenda of today is the following one. We will have the first presentation that is when the first topic is going to be presented by my colleagues from ASTEP, that they will introduce themselves in a minute. And the topic is the development of industrial solutions with limited installation, maintenance, and operation requirements. And then there will be a question and answer session. And after that, my colleagues from Friendship will discuss the creation of significant visibility to the potential of applying solar thermal energy in industrial processes. So we will try to analyze when the research meets the industry and how. Then there will be another question and answer session. And in the end, we will have a panel discussion where we will try to understand what are the main challenges and the possible solutions for a broad implementation of solar heat for industrial processes in Europe. And I leave the floor to my colleagues Magdalena and Mercedes for the first presentation. Please come. Thank you.
Hello, people online. And hello, and thank you very much for coming. We're going to present the project ASTEP, and particularly focusing a little bit on the limitations that usually industry have and how this project has tried to address them. My name is Mercedes, she's Magdalena. I'm from UNED and she's from UPM, Politécnica de Madrid. And I like to start these presentations with this slide, which is, I hope you can see it from a little far away, because we're all worried about the decarbonization and the renewable energies, and we talk about PV, and we talk about electric cars, and we talk about batteries and hydrogen and everything, but the actual elephant in the room is heating, and the heating is what is actually really pressing the climate goals and the security, energy security. So I really like the slide. What this means is that we have, of course, challenges decarbonizing. We have a big consumption in power of non-renewable energies. The yellow squares are the ones that are renewable. Of course, in transport, there's a big challenge to overcome too, but the thermal challenge is the biggest. We have the consumption of 51% of thermal energy, and only 10% is renewable energy. Can you click, please? And again, coming back to the slide, the priority right now for most of the times that we see is that we're gonna decarbonize the power matrix, which it's great. I mean, I am not an enemy of that, absolutely. We'll talk about electrification, especially regarding the transport, and we talk about energy efficiency. All these alternatives are absolutely necessary and are great, but they are not enough to overcome the thermal problem. And we have seen this slide this morning too, but it's a very good slide to explain that we have a problem with the industry, which is the 32% of the total energy consumed, and 74% of that energy that the industry consumes is thermal processes, which 90% is fossil fuels. So that is the challenge that we do have to address. And we probably keep increasing the energy demand of the industry. It's not something that we can actually reduce. So that's also another challenge that we have. And here is where the solar thermal technologies come. We were talking outside and during the lunchtime, and there were people saying that we have to improve the technology. I don't think the technology is such a big problem. I think the technology has TLR, technological readiness levels, pretty high ones. They have been demonstrated, they have been shown that they work and they are reliable. So I don't think that we have to keep improving the reliability of the technology. Maybe we have to improve how we can apply this technology to industrial processes. So I'm not saying there are no challenges in the technology, but there are other challenges when we apply the technology to the industries. Cost could be one of them, but costs are actually reducing. Here I'm showing two commercial examples. That's why I like to include them. One of them is industrial solar, which is here. I think it's industrial, right? The one in Jordan. Yeah. And the one on the top is Pampa Alvira, which is a mining industry in Chile. I like to show them because they're commercial. So it's good that to show that it's not only research projects or commercial projects. And there has been an economy of scale and prices are reducing. Maybe we still have to reduce a little bit more. But there are other challenges that we have to address. First is the high capital investment at the beginning. That's a very scary thing for industries. Of course, the reliability and durability. These systems need maintenance, and sometimes industries don't care about the equipment, and that's a bad thing. Of course, the solar energy variation. We cannot stop producing a product because there's no sun. So here's where we come to the last point. We need storage, or we need an auxiliary system. And of course, availability of land and performance in high latitudes are also challenges that we need to address. And here's where the ASTEP project comes. I'm sorry if it's very small. I try to put all the information there. The ASTEP project stands for Application of Solar Thermal Energy to Processes. It has 15 partners from Europe. And the main project is to demonstrate the viability of solar thermal technologies up to 400 degrees. It's going to be demonstrated in two locations, in 100 up to 150 degrees. For latitudes where the design is not usual, one of them is going to be located in Romania, and the other one in Greece. And the other important point that we are trying to address is the storage, so that the integration to the process is a little bit better. Well, I said most of the one of the features that the ASTEP system that we're proposing has is the modularity and compactness of the collector. But Magdalena is going to talk a little bit more about the system itself, so that it's easy to move and to install. And as I said, it's going to be validated in two cases. The one in Greece, which is a dairy industry, and we're gonna tackle the pasteurization process with which needs 8 bar and 175 degrees, and the one in Romania is 220 degrees, and it's gonna be used for preheating the some tubes, metal tubes that need coating. Now Magdalena is going to talk to you a little bit more about the technical aspects of the system.
Thank you, Mercedes. Well, I'm Magdalena. I was principally involved in the construction of the solar collectors and also the dynamic simulation of the whole ASTEP system. So we have two prototypes. One was specially designed to operate in high latitudes, and the other one is for low latitudes. And the principal objective of this solar collector was to challenge the main barriers in the industry with a low-cost collector and also easy to install, low maintenance, and easy to operate. So in the next slide, I will talk about these features. So here we have the solar collector for low latitudes. It's a Fresnel collector type and is mounted above a rotatory platform. So the square platform has wheels and can rotate, so the sun is always in the symmetry of the plane of the Fresnel collector. And the low cost is achieved principally because the mirrors are built with regular non-solar mirrors of 3 millimeters of thickness, and the process to bend the mirrors that you can see in the diagram below, it's very easy achieved with 2 grippers and endless through. So the shape of the regular mirror is adjusted with this mechanism. Another benefit of this collector is that also all the mirrors are fixed, so it has less tracking motors, and that also decrease the cost of the collector. To improve the efficiency, the Fresnel is tilt, and also the receiver has an offset to reduce end losses. So the next prototype that was designed to operate in high latitudes has a difference with the previous one, is that in this collector we have a 2-axis tracker, so the platform is rotating and also the mirrors are moving, so the collector can follow the sun trajectory. And this platform is smaller than the other one, it's more compactness. And another is, the mirrors materials and the mirror bending system is the same than the previous collector. So this collector will be, the cost will be higher, but also this collector can operate and produce heat efficiently in latitudes where actual commercial technologies can't. The receiver is a common evacuate single tube of 70 millimeters in both collectors. Then the system also counts with energy thermal storage. We have selected a latent phase change material storage because it has a higher energy density than sensible storage. So the volume will be in between 4 and 5 times smaller. And also the tank was especially designed for this project with the tubes have like a special metal insert with a flower shape that will increase the heat transference between the salts and the heat transfer fluid that goes inside the tubes. So here we have a diagram of the whole process. We have the sundial connect in series with the thermal energy storage, and we also have two heat exchangers to provide energy at two different range of temperatures. The priority for operate this system will be to operate with both heat exchanger connecting series at a high temperature set point, but in the case we have a low irradiation scenario, the first heat exchanger can be bypassed and the system could operate only at a low temperature, so that it will be achieve more efficiency in low irradiations scenarios. We have performed dynamic simulations in the MOLA software for annual performance in both sites, Iași, Romania, Corin, Greece, and we have found that the targets of energy were achieved. We have produced 27.8 megawatt annual energy in both sites. This is thanks to the two-axis solar collector for the high latitude. And we can also see that the land performance for the two-axis solar collector is higher than the other collector. So here we have, sorry if it isn't seen very well, but we have like the picture of 2 days of operation in summer and in winter. And on the top, we have the power results for the location in Greece for the dyer factory. And in the bottom, we have the temperature results. We can see in above that in summer, the sundial can provide the facility all the day and all the night energy to the process. But instead, in winter, the thermal storage can store the full capacity, and the chiller couldn't continue working at night. Also, we can see that the high temperature system works at 205 degrees, and the low temperature system works at 95 degrees. Then we have tested the system against a day with a lot of variation and irradiation, and we have found that if the thermal storage has capacity to compensate for the clouds, the system could operate and maintain the temperature set points correctly. Finally, we have carried out estimation about the levelized cost of heat. So we haven't finished with the construction of the prototype, but we have estimated a cost for the low latitude sundial of 179 euros per square meter, and for the sundial for high latitudes of 228. And that gives us a levelized cost of between 45 and 50 euros per megawatt hour. But we thought that we think that thanks to scaling up and other benefits of better analysis of the sundial, the sundial is a very small prototype. So scaling up the prototype with mass production, this cost could be reduced like a 30% to achieve lower levelized cost of energy. So to sum up, with the ASTEP, the ASTEP annual energy was optimized with this control strategy using two temperatures demand. The performance of the system was reliable also in days with clouds, and the sundials at low latitude cost was driven down principally because of the use of seaward motors and the mirrors bending system. Also, the sundial high efficiency and compactness is achieved because of the two-axis tracking system. And to sum up, that the ASTEP project was present with the need of the industry in mind, and part of this objective to start where to develop the technology easy to install, maintain, and operate. So if you are interested in the project and you want to follow up, you can visit the webpage and subscribe to the newsletter. And also, I want to present to you, this is a group funded last year. It's called Women in Concentrate Solar, and the aim of this group is to supporting and promoting women in the CSP sector. So if you are interested, you can go to the webpage and find about more actions of this group, and also to register in the newsletter. So thank you very much for your attention.
Yes.
No, it's the next slide.
No, the questions. I mean, if there are questions online.
How
do we know? You know. Okay. Okay, sorry then.
Thank you. Thank you. Thank you, Magdalena. Are there any questions?
Yes. Is the prototype being also thought to be developed for commercial projects?
At the moment, it's only gonna finish in tier R5. So not at the moment. Maybe it needs a middle project, a middle research projects to reach market. So at the moment, it's only a prototype. But if you're interested in the patent, I mean, the products are being patented and everything, and the idea is to follow up with a project to reach higher TLR. But who knows? I mean, future is uncertain, right? Mm-hmm. Let's see that the pilot works fine.
And should be commissioned pilot?
You know better when it's going to be commissioned, the pilot.
Hope we finish this year, but I don't know really.
It's complicated, the pilots always, but the idea, they're working on it.
We are building it, and
when it's finished, you can come see it in Getafe. It's here in Madrid. So.
And another comment, you mentioned this women's SP. Also, so see that we don't talking about women also in engineering in general, but also in this SP.
Yeah.
Are you also collaborating the women in
I think they're trying to find like sister groups.
Mm-hmm.
I don't know if they have contacted them or not.
I think yes, it's a very new group, but they are in contact with these other groups of women in renewable and energized women, all that kind of groups. This is more specific for the CSP industry.
By the way, the expert database that they are creating, that is open to everyone on CSP. I mean, even men. I mean, it's open. So it's just to have just to be clear, it's not only women expert database. It's men and women and everybody in between, and everybody's welcome to sign up. So that it's not confusing that only women can sign. No, it's for everyone.
The idea is to support women, but in the database, everybody
can be there. So just to be clear. Thank you very much. Any more questions? No? Okay.
Okay, then we can go to the next presentation from Friendship. Yeah, come here. So you.
Okay, let's start. Okay, good afternoon. We can start introducing ourselves probably. Yeah, you can start. Okay. I'm Puneet. I'm working as an innovation engineer in a company called Solicon, which is located in north of Sweden, a small city called Härnösand. And we are I'm an innovation engineer. I'm particularly looking into how can we combine our thermal solution with innovative technologies like thermal storage and heat pumps and photovoltaic and other options. So, and my expertise, so-called expertise in high renewable heating fraction systems.
Hello everyone, I'm Pierre Dury and I'm working in the National Institute of Solar Energy in France. I'm solar thermal engineer and we are mostly in charge of, in this project, to the visibility of the solutions and the creation of material, educational material to enhance the visibility of the project.
Great. Okay, so yeah, I think I don't remember what's the. Okay, so I will start introducing Epsolicon. Probably that's the best thing to do, just to give a background. So as I said, here are we located. It's north for us, but it's if you're looking geographically, it's exactly at center of Sweden. Small place, Härnösand, a coastal town with an annual radiation of less than 1 megawatt-hour per square meter and annual ambient temperature 4.5. So perfect place to start solar thermal business, right? And what we do here is, that's strange. It misses some info. Anyway, but it's basically a parabolic trough collector, a small scale. Parabolic, as we call it, small scale is when we compare it to large CSP application, which are very large parabolic troughs used for power generation. And we can produce temperature of 260 degrees Celsius, and we have optical efficiency of 76.4%, and the collector is certified by Solar Key Mark. And we can generate hot water, hot air, whatever heat medium we need to heat, and of course steam up to that pressure. So up to 8 bar steam is when we combine our collector with steam compressor, but collector itself can generate steam equivalent to 160, which is I think 4.5 bar gauge. And what we do is basically we don't sell our collector, but our business model is to sell the production line. And that is so these collectors can be mass produced locally. So what we do is we find partners in different countries who are interested in renewable thermal technologies. Then they contact local industries there. Then once they have reached a threshold volume to sell those collectors, they buy production line. We set up those production line and then they sell it locally. So you have a low cost of the collectors, probably 1/3 of the cost that you will get in Sweden, for example, and then you create local jobs and synergies there. So that's the idea. And of course, we do small installation because solar thermal, we know how the market is. No one will buy a production line of 4 million euros until you see that the technology is working. So we have done small installations at different places just to bring confidence in customers' mind. And then we have a production line in Sweden, as you see here, and then we have production line in China. And recently we have sold 2 production lines, one to Canada, another to Egypt, even though Egypt is a tricky market. But yeah, we managed to sell it there. And then I give floor to Pat.
I don't want to present this slide.
Okay, sorry. Yes. One of the goals in Friendship project is, of course, the need for visibility. How do we push solar thermal solution and more visible under the shadow of many other solutions that are popular, let's say. And I say here, solar thermal is hidden and less marketed technology solution. There are several reasons for it, but I think there are few technological suppliers. Very few people know about it. There are very few installations compared to other renewable electricity technologies, for example, and perception of being complicated. And this was what discussed in the last session as well. And if you think about complicated, say if I compare PV and solar thermal, PV seems to be simple, but PV is like a photon being going on a panel, clicking up a photoelectric effect, electrons moving, generating electricity. That sounds more complicated than a water pipe heating the water, right? But it still work. PV work, and customer don't need to bother about all these physics of PV module, and that's why it's so simple. And this is what we need to get in solar thermal market, a ready-to-fit solution which works, and customer don't need to see, is it generating steam or not? And that's when I think this perception will be away, like it's a complicated technology, but I think it is really not once it's standardized. And we don't want this to happen. This is an example actually in Gothenburg in Sweden. What you see here is actually flat plate collectors which were installed for solar district heating, and then it was PV who took over. So the customer used the same structure of photovoltaic modules to put PV modules on top of it. So it was, it's not, now you see it's, no, it's not shadow. It's the PV modules. PV modules useful. It's not the PVT solution that you see. It's not PVT. So we don't want this to happen. This is why we need visibility.
Thank you, Puneet. So at INES, in the Friendship project, we were in charge of create and enhance the visibility of the solutions and the different bricks that compose the solutions. So we propose to produce educational videos, e-learning videos for the potential end users of the solutions to explain the technical content of the project and to provide industry and decision maker knowledge to understand the solution and maybe be more confident about it. We approach industries also with acceptability study, and we communicate on the two subjects on the social media and website. We set some indicators to these two tasks. The number of industries reached with the videos and the survey, the response rate of the questionnaire, and the number of views of the videos. So about the acceptability study, we want to obtain the industrial views on the solution, the global industrial view, the first views they had about the solutions. To do that, first we create industrial context database with all the members of the Friendship project, and we create the questionnaire on two subject, large subject, the acceptance of the solutions. How do you think about solar thermal globally? And evaluate also the compatibility of the plant with the solution proposed by the project. So we used two strategies to disseminate this survey. We begin with a quantitative approach. We use the social media and websites and emails to diffuse the survey in mass and to touch the maximum of industrial, to obtain numerical results and statistics. And also we do a qualitative approach with the close industrial partner we have in the consortium to obtain like more specific answers and more specific data on the views of these industrials. About our other activities to enhance the visibility, we create e-learning videos about the project. The first video has present the global context of the project and the global vision of all the bricks of the project without enter in the details. And we put this video in the survey. The survey we sent to the industrial. We create also 3 videos, more technicals, destined to the decision maker, but also more specifically to the technical members of industries. We bring details about all the bricks of the Friendship solutions, about the solar collectors, the thermal energy storage, the chillers, etc. It's accessible on the Friendship website. And the fifth video we will produce will be the presentation of the prototype, which is in constructions in Grenoble, in the DCA, and the commission will be maybe at the beginning of 2024. So the results yet of the survey, I put some data and results so far about the survey. We get some numbers of impressions on social media, some interest about the project. It enhanced the visibility of the project. We make some meetings with industrial to present the project and have more detailed view of them about their constraints. And we also count the views of the video. So yeah, so also you have the response rate of the survey. We have very few results with the quantitative approach we did with the survey. We have just 2% approximately of answer of the survey with the emails and the website, the social media posts. But when we approach the industrial and we talk with them about the project, it works very well, and we had rich answers about them, of their constraints and their approach about the Friendship solution. We also had an article in specialized press, French specialized press, Technique de l'ingénieur. And we create contacts, really close contacts with some regional agency of industrials in France with these activities. So this work gave an indication to us about the difficulty we have to reach industries and make a contact with them and assessing their interest to the solution. And it's really a concern about, I think, the solar thermal solution is to create really good arguments about the solution from the research side, and yeah, it was very difficult to reach the industrials. We bring also educational material to make this kind of solution more familiar and attractive to the potential end users of the solutions. Yeah, so we discuss about the solutions, and one of the most with the more promise to enhance the visibility of solar thermal and is maybe the hybridization with other technologies to enhance the growth of the field. And I will let Punit to discuss about this topic. Thank you.
Great, thank you, Ben. Yes, so solution, as Per said, basically we need more pilots. Actually, probably it shouldn't be pilot because I think solar thermal have seen enough pilots now. it should see more commercial scale project, large scale projects operating as defined in the project proposals. And then we need hybridization with other technologies. So I will touch these 2 points. I give 2 examples of here, more pilot. They are key to obtain the stakeholder confidence, and of course they are good learning and research of possibilities, even though they are installed on customers' premises. And there have been a lot of pilots on hot water generation, 90-95 degrees Celsius, but there are few basically for steam application. And that's where it gets very complicated, because steam system itself is, it's not so easy to tackle. So we have done some installation, which I would, I need more pilots for innovative concept. I show example here. I will show 2 pilots, and these are recently commissioned pilots by Epsolicon, and they are not done as part of any research project, but they are basically implemented using customers' money or in heat purchase agreement as well. And what I would like to promote here is that all stakeholder, any stakeholder who is here or as a researcher, you are really welcome to contact us, and we will arrange a visit, and you can see the pilots. And even though if it's even if it's other technological supplier, we are very open. You could say no problem. And this is an installation in Karlsberg, Greece, in Thessaloniki, for a brewery industry. It's a solar field of 660 square meter, as you see, and it generates steam at 150 degrees Celsius. So the steam generated here is being fed to the pasteurizer of the brewing process, and then the system is expected to generate 354 megawatt hours per year. And we have just few months of operational experience, but we are satisfied with what we have got. And the idea is that we will extend this field further to a larger scale. And this is another example, which is in Italy, in Bari, and it's a beer company called Peroni, probably. It's a solar field again of 660 square meter, and here it co-generate both steam and hot water. So it generates steam at 150 degrees Celsius and also generate hot water at 85 degrees Celsius. Both is being fed to the pasteurizer. And it's a specific case because pasteurizer can take both steam and hot water in this case, but that's not usual in industries. So, and we have also employed energy storage tank. If you can see here in the picture, do you see? Yes, exactly. So this is the storage tank here, and this is a containerized solution called Solar Central. That's basically all the balance of plant that you see. And these are lines which goes to the industry for steam and hot water here. And well, we have talked a lot about solar thermal, and I think probably everyone in solar thermal world would agree that there are many problems. And one of the biggest is storage. That storage is very expensive, and the implication of that expensive storage is that you cannot reach very high solar fraction or the percentage of demand that you meet for industry, right? So how do we, and if I am a solar supplier, I go to industry, I say, hey, I have, yes, I looked at your data and so on. I propose you 50, 60 euros per megawatt hour of heat, but we just meet 20% of your heating demand. Customer is like, yeah, good, but what do I do with 20%? What about the rest of it? Rest of it still be using fossil fuel. So that's where I think we should leverage on the advantage of solar thermal, which is that it can produce very low levelized cost of heating up to limited solar fraction, because the curve for levelized cost of heating just keeps on increasing once you introduce storage. So there are 2 ways to tackle it. Of course, there is a need of better storage, a cheap storage solution, A, and B is hybridization or working with other technologies and not seeing them as a competition, but as a complementary technologies, right? So here I will touch upon, this is an example of what I showed you for a real case industries. On x-axis is solar fraction, percentage of demand met, and on y-axis is LCOH. And what you see here is that you start from 0 solar fraction, you go up to 15, 17% solar fraction. The levelized cost of heating is flat and it's very low. It's 25 euros per megawatt hour, very attractive for customer. And now if you increase solar fraction from 17% to more, you have higher mismatch in the demand and production. So you need storage, and storage makes sense. It increases LCOH a bit, but then after a point it increases a lot because you cannot, the storage cost increases linearly, but the energy that it's stored doesn't increase linearly. So of course there is an increase in the cost. So we should use this low trend up to maybe 30-40% here when it's very reasonable, when where no other technology competes probably, and then use other better solutions for rest of it until we develop a good storage, hopefully. This is an example of a combined solar thermal and steam heat pump solution, which is concept we really push. Here what you see is that if you have an industry, you generate solar thermal, you have a solar thermal field which can generate heating directly during the daytime, and this steam is being fed to the customer during daytime. And then whenever you have access, it is stored in a thermal storage, but only for a few hours, because after that it doesn't make economic sense. And then that storage is being discharged during the night. But at the same time, whenever you are producing more, you can also store using a low pressure storage tank below 90 degrees Celsius because it's cheap. And then you can use it as a source for heat pump. So it's a win-win situation. You are utilizing the excess heating from solar. At the same time, heat pump operates at better COP because it's getting high temperature source from solar thermal. And then you meet rest of the demand from boiler if and when necessary. And if you cannot generate high enough pressure, then you also have option for steam compressor and so on. So this is just a concept, but then there is another concept which is combining solar thermal and PV systems together, because we know PV, it can compete solar thermal on cost basis, but it cannot compete on area basis. It needs 2 to 3 times more land area to produce the same energy. But again, PV can charge a very high temperature storage, a cheap storage solution, which solar thermal cannot, because solar thermal solution in the market, maybe they can reach 250-300 degrees Celsius and they cannot go beyond that. But on the other hand, if you have a PV module and you have a resistance heater, which can go maybe 700 degrees Celsius, it can charge a very cheap storage, such as here is an example based on sand. So during the daytime, you generate heat, you feed it to the industry, meeting 25-30% of the total demand. And during the daytime, solar PV will only charge the storage, and whole night time you will discharge the storage. And we actually did now there will be a publication soon, which is accepted, which will compare such system with when these technologies are used individually. And what we have seen is that combination make a perfect sense. It's like a marriage made in heaven. Okay, so summary is that despite the high potential of solar thermal, and I think the potential is still hidden, we need to promote it more, and then we also need to hybridize it with other solution, and we need to tell them that we are here to work with you. And then we need, as Pat said, more educational material, more pilot industries, more communication and success stories. Is that all? Yeah. Great, thank you.
Questions? If not, maybe I have one. Yeah. Like we're seeing that actually, like the questionnaire was not very successful. So if you had to write the project again, would you write it differently? Like instead of questionnaire, would you put something else? Or would you stress more or give more resources to another part of the work you did or that you did? I don't know. Like, what did you learn from this experience of the questionnaire? Maybe it's not that successful, not that relevant. Maybe. Or...
Yeah, maybe we were too far of the needs of the industrial we talk to, we speak with. Maybe it could be great to have more link between the different projects we saw this morning, like Ship to Fair. There is a lot of pilot industries, and maybe it should be good to link the two, and yeah, instead of recreate a survey and go to industry that we don't know nothing about the solution. Maybe it will be good to link the industry who are pilot industry in different projects and other industry that are new in the field. And I don't know how, but
networking.
Yeah, networking with the other projects. Yeah, the sister projects. I don't know.
question. I think, well, we also have experienced that the lack of standardization
Yep.
on software industry is also one of the barriers. We will identify ways to try to standardize some things, because I think that's very complex, because the technology itself, they work differently. Even with parabolic collectors, there are different ways of parabolic collectors. And I think the advantage of PV is that although the modules are big and small, people don't talk about which material you're using that. So they know that something works, they just put a flat plane there and it works. I think in this case, for solar thermal, the options are still quite wide. It's good that they are wide, but the standardization, the way that people understand that this works in a certain way, because for the industry, I think they are afraid of experimenting.
Yeah.
Are you exploring this standardization?
Yeah, we have tried, and we were part of IEA SFC Task 64, which is on solar process heating, and we were actually participating in the standardization of subsystem, for example. And even there, the main conclusion was that it's just so difficult to standardize, because there is so big variety of steam generation methods, as well as how the collector is controlled. So each manufacturer has its own way of controlling the collector system and so on. So you can, we ended up doing some standardization in instrumentation instead of balance of plant. But I think there is some deliverable, I remember, on the standardization of BOP, what's possible standardization is. But I agree with you, it's just so big variety. So customized solutions gets expensive, that's the problem.
And maybe I have another question. Like at some point in the presentation, you said that this solar thermal has enough pilots, but then how would you get the visibility, and how would you get to the customers know your product without pilot? Like, do you have something in mind with maternity, or you already
Yes, I think, as I said, like we need more bigger commercial project, because that's only that will keep industry floating, let's say. As I said, there are few technological suppliers, and pilots are really good, especially on research and development purpose and so on. But if you want to make turnover, bring some money, and keep the company going on for next few years, then it's important that we do bigger projects, especially on steam basis. Now there are very few, as I said. But on the other hand, there are sub-components which need to develop, like thermal storage. So we need pilots where we can integrate these new storage concept with collectors. We need pilots where we can bring this concept like new storage techniques or PV modules or heat pump and combine it like we are doing in this project. So we need pilot in that direction, of course, to keep research going. But at the same time, we need more bigger projects, more commercial projects, which can
pilots always the starting point.
Yeah, exactly. A pilot's also starting point. Yeah.
Well, on the online, I think it's related to the previous question about the questionnaire. Valerie says about the questionnaire proposal, invite people to visit the demo. So basically, at the end of the project, I have face-to-face meeting to fill the questionnaire. After the visit, will be not sure.
Yeah, maybe we can move forward the deliverable of the survey and add to the final event the training session we have to do, the visit of the prototype. Speak directly with industrial, with the solutions close to us, and maybe we will have more results. Yeah.
Maybe the lesson learned is the timing of the question.
Yeah, the timing is the reason.
Now, the point is that related to the pilot. We have seen many research projects on the pilot in the past that they were not followed up after installation.
Yeah.
And I don't know if the European Commission is changing their mind, but I think the problem is that in the research project that we do 3-4 years project, you implement something, and if the business does not go well, you don't leave it as it is and go ahead with your other working life. But the pilots, we have experienced, I was talking to Mercedes, that some pilots, they are actually bad experiences.
Yes.
And it's not a problem to be a very experienced pilot, but the problem is no follow-up to try to fix that and then to try to change the image, because also we have seen commercial projects that did not work well, and at the end of the day, as the market is still in the infancy, it's hard to show that something works if you have bad experiences that work in the past.
It's one of the biggest problems in the European project work, but how do you organize a follow-up? Like, what is a successful project, what is not so? Like, I think it's one of the biggest things of the horizon, not just the horizon, but it's also very hard to implement an effective follow-up program in the scale of Europe is working, but I think it's that the European Commission is one of the open questions they get at the moment. Because Europe is investing quite a lot in the last years in research, but then the results are not the same level as the money they spent, and that's mostly because of the lack of follow-up programs. So I think that the solution will come in the following years, and hopefully it will also.
My suggestion would be, when you look at the TRL level, you put a cut line and say the project is above this TRL level, you give the option to have some follow-up support, or you open the discussion from the beginning of the project, that the parties should already from the beginning agree that this has to be followed up, because the level is already high enough. It's not like a pilot in TRL 3, 4, 5. And then maybe to try to push them to continue that, because if you only do a pilot and then you have the results after 1 year of test phase, and if maybe it did not go well, it's probably could also be the case, but if you went well, or how to make this go well. And this, I think, is the responsibility also of the funding body, because they want that this goes for them in the market.
And very often they are abandoned in
Exactly.
So it's a waste of money.
Yeah. You create knowledge, but like we like to change to market, you need things to show that it's what works.
Yeah, I agree.
Any other question? Then we can go on to the next session, the panel discussion. So maybe you can all sit there so that the camera can
Like that.
Yes.
I think we have discussed video first. But we can keep discussing, no problem. I would have standing actually.
Okay, so we prepared this panel discussion session where we were thinking to discuss the challenges and the possible solutions in order to implement the SHIP systems broadly in Europe. And I wanted to start a discussion with a statistic that I found really interesting from the market statistics from Solar Heat Europe that says that in Europe, that's a statistic from 2021, 90% of the solar thermal systems sold in Europe are also manufactured in Europe. So it means that our industry is a net exporter, so they meet the demand in Europe and they also export in other continents. So this is pretty positive for Europe, right? But when it comes to the implementation of SHIP systems in the energy intensive industries in Europe, numbers are still very low. So this panel discussion has the objective to try to understand to analyze the challenges and then the possible solutions. And this session will be moderated by myself and by my colleague Anouk, that did not introduce herself, maybe she can. And so the first question is.
So as an introduction, my name is Anouk Muller. I work at CEA. I was also part of the Friendship project that I will be glad to present it in another workshop right after, so stay tuned. Exactly. So I was working on the chiller part of this project, so we didn't talk about it at all, but I'm still there to try to challenge my colleagues with questions I have on their topic. So my first question is, I know that we've talked about it a little bit. What are the key technical bottlenecks? Because fact is, as researchers, we're still asked to work on this topics of how to bring solar thermal technologies, meaning that it's not done yet. what do we research exactly? So what I've heard of your responses so far is the storage is a key issue that we still need to research. Would there be other things that you have in mind that should be up in our to-do list as researchers right now?
I think, well, I'll start. Storage for sure.
Yeah.
From one day or not, for another, I mean, short-term storage, of course. Also, a very difficult question to answer is even storage through the year, because if you have an industry, the demand might change in summer or in winter. So if you could move the demand around somehow, that would be great, or the production. That would be a technical challenge that I have no idea how to solve, to be honest. And finally, I think everything higher than 250 degrees, it's still a technical question to solve. I mean, of course, steam generation, there are some things done, but higher than that, there's also possibilities to solar heat to be applied, but it needs to be much more research. That's for sure. But I think those are for me, the more important aspect right now.
All right. And you?
Yeah, I would say, I think storage, of course, what Mercedes said, and also I think more operational experience with high temperature installation is the key. And this is how PV has learned basically. I mean, if you look at PV history, they installed, there were several errors, the market was big, everyone came together, the solutions were fixed. And in solar thermal market, it's slightly different because you have just few suppliers, few installations, variety of installations, but very few. And then whatever experience get, there is lack of a common platform which can bring together different suppliers and discuss what can be fixed. So we need to have this learning curve, and it should be pretty fast, I think. And we have seen this success in at least hot water market. If you see the learning rate, it's quite immense. But with steam system, because industry is now getting awake, this was never the focus. No one used to boast about their boiler, how efficient their boiler, how carbon neutral their boiler is, but now they are concerned. So I think I really hope that the market survives, and then we will see more and more installations, and then the experience will help us.
Is there anybody who wants to add something about this topic?
Maybe I can, because we lots of commercial projects, not only research. And from the commercial field, I think one of the main challenges is to understand the demand. It's very rare that you go to a company that they know the demand. They might have the gas measurements, but they don't know how it's used. And I think for solar thermal, that's one critical point. It's not so much for electricity, and also electricity is easier to measure. But I compare to the photovoltaic example, but the thermal part, when you look at how much the steam consumption they have and where they use the steam consumption, when to use, and peaks on that, like there's a lot of assumptions that the solar thermal provider have to make in order to make proposal. And especially when the integration, when I was talking about integration, the supply level and the process level. In the supply level, we keep out many of these assumptions. I don't have to think much about the details. But when we integrate in the process level, then it's more critical, because if this process does not work, what to do with the solid? And if you're integrating here and there, the complexity is even more, because the controller has to understand this is stopped, this starts, storage is charged, storage is discharging. And I think this is one thing. I don't know if research project can do it, but it's a campaign that we should have. Like, if the industry wants to decarbonize, they should learn and understand how they use it. And I think this is one of the main challenges that
I think you're answering the question I wanted to ask later, so I will ask my question so we can, maybe somebody wants to add something. My question was, and I would have loved to get the answer from the SPIRE industry on that, because they were part of our project, exactly those difficulties for the integration in industry specifically, meaning not just from my part, from my lab, it looks simple, but when you work with processes and then it gets a lot more precise what the needs are, what are really concretely the challenges, meaning, right, how do you work with batch loads or not, or constant loads, and this kind of stuff that we might not understand so well when we're not one foot in the industry. So does somebody know something of this topic of really in real life industry, what are the challenges to implement or integrate solar heat? So you said the knowledge of your own processes actually, and the understanding of what you need, which is not mastered, maybe not always.
And I can add, I think integration point itself is a bit ambiguous. I mean, because there are so many different integration possibilities. You can integrate before the boiler, after the boiler, on the process level, temperature requirement, and the heat load is so different. And most of the time, customer don't know. I'm still looking for my ideal customer who has like minute-wise record of how much heat they consume, but you never find it. So, I mean, that's one challenge. And of course, if you look at once you have decided on an integration point, I think then it's not so difficult. For example, I talked about pilots here. If you look at how the steam is integrated, it's just pipe connecting a pipe, as simple as that. I mean, but finding that that's the right integration point or not, that's itself is a question mark that need much more engineering, I would say. But once you have agreed on an integration point, it's pretty simple, I think.
I think you also have to overcome I don't know if a cultural open operation mindset that in the industry, the technician that turns on the boiler doesn't care about the boiler much more than, okay, I'm going to put it on, I'm going to put it 50%, or I'm going to put it 80%, but it's that easy. It's just a button, and that's it. Oh, I need more energy for pasteurization. Okay, turn it a little bit up. But that's it. That's all he has to learn about the technology. I need more energy. I have more energy. I don't have to worry about anything else. With solar systems, it's not that easy. So if you expect the technician that is worried about producing, I don't know, tomato cans, that he learns about solar, no, that's not gonna happen. So you have to find a way to overcome that you need the solar system to be as easy as a boiler. And I think that's a very difficult thing, to be honest, because you have to tackle all the challenges that you're not always going to have the solar system. So that I think that's a very interesting thing to solve for really solar heat to get to the market.
Simplification, right?
Yeah, not the technology, simplification for the user. I mean, this is like iPhones. Everybody has an iPhone or an Android. I mean, but it's because it's easy, or because you just have to have a button. My grandma can play with the phone, right? Or my 3-year-old kid. And when you have a Linux computer, not everybody can use it, and it's much more powerful, and it's great because it has great possibilities. But you need to have a way of overcoming that inertia of difficulty, let's say.
So it should be intuitive.
Yeah, it's
Also for non-experts.
Yeah, because it's not their focus. I mean, the technician doesn't want to know anything about the solar system, and he's annoyed because he has to clean it. Come on.
Okay, so self-cleaning and intuitive systems.
I mean, I'm exaggerating, but it's actually like that. I've been in industries with collectors, and they are annoyed because they have this big thing they have to clean every week for it to work, and they have to check that the pump is working, and they have to. It's more work for them that is not actually making them produce more tomatoes, for example.
If I can put a bit blame now on industry side, I think the existing industrial systems are actually not designed for these solar systems to operate efficiently. I will just give an example of a real case in South Africa, which I visited. They were generating steam at 12 bar pressure out of boiler, then reducing it to 2 bar right after the boiler. That steam at 2 bar goes to a process which is used to generate hot water at 37 degrees Celsius. That's the existing system.
Yeah.
So I think companies need to think more and more on how their system can be efficient, like pressurized hot water system based or low pressure based system. They are the transition, I think, that they should make.
Yeah, that's true. Yeah.
Okay, so it means we cannot only retrofit existing processes, like we take the industry as it is and we just change where heat comes from, but we need to question how the processes are working and sometimes say this is just too inefficient to work with right now.
If you ask them why your boiler operates at 12 bar, they will say because it can. because it
Because
can
it's what
operate.
it does when it's
Exactly.
That's the standard system that they sold to them, so that's how it works.
And I guess in the same industries, when you arrive with I don't know how many square meters of collectors and they have no room, and as we've seen in other examples, for example, there is an existing facility, and then you have to fit your collectors in something which is also physically difficult, like the roof might not accept them, or you have shadow. So that's it. Your turn with a question,
Yes.
I guess.
Yes, actually. Yeah, we already answered this question partially, like talking about exploitation and commercialization. What are the main challenges to bring this when you bring the ship systems to the market? And yes, maybe you can start.
So maybe we can summarize what we've said on this topic already. So if I remember right, we said there is a little bit of a lack of networking done.
Yes.
To give visibility, like to give a little bit of visibility to everything which works already. That was one big point, I guess. What else did we say already? Actually,
The big commercial projects, maybe
Yeah.
are lacking.
And I think there are several other factors. It's really never only one criteria which rejects a project. It's just small multi-dimensional problem which comes together and maybe it's not suitable anymore. It's a hard ladder to combine, because I mean, especially in this technology, which the demonstration level, at least on Steam level, is so low. You have to also climb the psychological level of customer. Should I invest in a technology and taking that risk? Should I give away my land and I can probably build another factory tomorrow? If you cannot install on the roof, I mean, installing on roof is a big advantage, but I would imagine like it's not so usual that you get flat concrete roofs all the time. So that's another problem. And I think no one really knows how the heating market will evolve in the next 5 to 10 years. That's a skepticism in everyone's brain. If someone is sustainability manager and so on, like, okay, if I install solar thermal, now what about it? I don't know, some hypothetical energy technology comes tomorrow which gives me energy free. What do I do? So my investment will be waste. I think you have to basically overcome all these problems.
But we saw it this morning as well. Like, I think until very recently, one industrial would think of buying like solar system, for example, because like to save money because it was cheaper. Nowadays, there's still this component, it's still very important, but still the possibility to get certifications, as we saw this morning with the Roda winery, or because nowadays, like if you are not sustainable, then you lose clients because people are more sensitive to this topic. So maybe this could be a good leverage for commercialization in the future.
Yeah, I agree. I mean, I think more and more multinationals should come forward, especially those who are in public sector where shareholders are invested, saying based on their sustainability goals, and if they don't meet them, then there is a risk they will lose market. So, and multinationals, I think, should put more money into like testing these innovative technologies.
And my point is also they will not care that much if it's expensive technology, because the gain is somewhere else. It's not on the money, or at least not immediately, but on the image and on the certifications and so on.
Yeah.
So I think that's a good leverage for the collector producers, manufacturers, but for all of us that work in the sector. Any other thing? Then we can go on. Oh yeah, that's my favorite question. No, yes. Like, because I wanted to get a bit more creative at this point of the workshop, and so let's pretend that reality does not exist. So in an ideal world, yes, in an ideal world with unlimited time and fundings and resources, what would you need in order to implement the ship systems in Europe like Broadway? What's your desire, your wish?
I think we need a rocket so we can escape the atmosphere and go to sun and produce there, probably, if the reality doesn't exist.
Yeah, good point.
I would like a very big survey on demands, on the actual demands of real industries. Like most of the industries, you go there and measure what they're actually consuming and when they're consuming and how it relates to production and everything. I think having that information would be very useful for providers.
You mean to have data, like to have the
a lot of that on the industries, so providers can have the information to really make calculations, and then when you have that information, you can actually even, okay, I'm gonna start calling, and you start with the phone and calling, okay, this demand makes sense for my system, and I can call, hey, listen, I have this system, are you interested? Hey, this demand is not interesting. I think that would be a very, very interesting information to have, but I think it's realistically, it's very difficult to have the demand of every industry in the world or in Europe.
Also, because as they already say,
They don't even know. No, that's why. I mean, you have to go there with the sensors and install it and everything.
And it takes time and it takes
Of course.
resources.
But I mean,
but
we
it's
said
not
a realistic.
No, yeah.
I have all the time and money in the world.
But there is maybe some hope with so many companies going to energy management systems,
Yeah.
right?
Yeah.
So I guess they keep their data like
Yeah, completely private. But
obviously, but then I guess little by little the knowledge is going to be there.
probably for big companies.
Yeah.
I have my doubts on small companies.
Yeah.
But yeah, probably for big companies, you will go there. But I think that would be a very good first step. But
Well, for me, in a perfect world, I would like that industry could think their process using renewable energy and not using the fossil fuels. For example, what he had said, that if you need a demand, I don't know, 45 degrees, using solar collector is very feasible. So why don't you go from the beginning for that solution?
The system is also the infrastructure around.
Yes,
Because sometimes
also.
there are not the space, or I don't know, the roof is not designed to.
But think the industry from the beginning
Yeah.
to include the renewable energy.
This is a big problem, especially in Europe, because we have a lot of old plants. We saw it with Friendship recently in Germany, and that was the biggest problem. Like the plant was constructed with the ideas of 1 century ago, and then it's very hard to turn it even more sustainable one, because there's more space, not infrastructure, there's not, and the system really needs to be adapted. But this is the consequence of, yeah, good thought. Any other?
Yeah, I don't know, maybe I think there is lack also in technicians skilled for the implementation of solar technology. So maybe more technicians skills in every company who can, understand the process and talk about with his CEO or I don't know, and deal with the installations and the maintenance of the process.
Yeah, but I think this might come soon because of the sensitivity
maybe.
is changing.
Yeah.
So maybe among the four, maybe this is the most feasible one. Medium term. Let's say. Thank you.
Can I run with some lectures?
Please.
We just started another project with Mercedes yesterday, the kickoff meeting, which is then also using artificial intelligence to try to create a model that will combine technology. So I think when I do work, the data that she was saying that the company should have, they will be available. And then we would have like a generative AI, like ChatGPT version plus, that will tell us what is the optimum. I think that's the hard time for the solar thermal technology to find what's the optimum. Regarding collector size, regarding the storage size, regarding pipe size, and so on. So basically, it's all related to data manipulation. Someone's like in Excel or I don't know, using Python or whatever, language trying to solve problems. If the data is available for machine learning to work on it, like then will make the life of everyone easier.
And would help in customizing the solution you have.
Exactly.
Because the data are important, but it's also even more important how you use them.
Yeah, that's true.
Yes, that's complementary. So.
Next project.
Next question. Okay, I think we already talked a bit about it. Is the current energy situation in Europe, like with the prices changing very fast, evolving very fast? Is it rather seen as a chance that finally people might turn for chip solutions, or actually rather like a threat for also chip manufacturers? Or what would be your vision on it, short term or mid term?
Yeah. Well, as a technology supplier, I can say, I think fuel prices, of course, when they were due to this crisis, the gas prices went quite high. Then there was a lot of interest. Someone said in the previous workshop as well, I think for Dimitri's probably. And they got a lot of queries and so on, and then we sent proposals. But I think this time constant is so high in solar thermal industry from the time you get the proposal versus time you make the decisions. And there are so many different number of variables that decide that the prices went back to 20 euros per megawatt actually. Probably, yeah. So I would expect, I think there are two things to happen. One is that European Union legislations, of course, on the carbon pricing and so on, which will push the prices at one point. And on the other hand, I think responsibility also comes on the industries and users, basically, because I would like industries to be more open-minded and look beyond the shallow parameters of payback periods, for example, maybe payback period of 1 day. I mean, that's what industry really expects. And if you look solar thermal in a way that it's a technology who is replacing part of 50% of your demand or 30% of your demand at the same cost as boiler, I think it's a great deal, really. And then it reduces directly 30 or 50% of your emission, even though you don't get as attractive payback as you would expect. But still, you are getting the direct CO2 emission without increasing any euros per megawatt hour of your current heat generation. And that's where the big problem is, they don't want to invest capex. And that's where I think the solar thermal is more a financial challenge than a technical challenge. Technology, I think, is quite mature now. We need more good business models, basically HPN. We need more stakeholders who can come and invest money and leverage this HPA arrangement. So that's the change I would like to see, probably.
But don't you think that now industries know that prices also in Europe can be pretty changeable and volatile? So maybe they could invest. Like, do you think they understood that they should invest because prices can change pretty quickly, pretty high? And
yes, I think there is a growing awareness.
Yeah.
The market is completely different from what it was, say, 5 to 10 years ago. It's more and more significant, and I mean, this is why I think we will have more small installations, because companies would like to invest some money, not all probably, but some money, and see how the technology performs. And then if they are satisfied, then they will put money for a bigger installation. So I think this is the trend we are going to see, hopefully.
so the rise of prices was positive enough.
Yeah, in a way.
Okay, then this is almost the end of the panel discussion. So I'd like to ask you if you have any plans, or if you already start working in follow-up projects, as these projects are going to be over in 1 year. Do you have anything in mind, or you have started already? Or if you're working on parallel projects that are related?
In the case of ASTEP, we are working on a follow-up project to increase the TNRL. So hopefully we will get it, but we'll see. I mean,
Then for Friendship, we submitted a proposal recently on TRL 7 higher hybrid systems, so it was also connected.
exactly.
So we will see. And and also other projects already working on.
As Ivo said, we just started a new project which is called SUSHEAT. It tackles also the heat pumps, and also there's a digital twin to try emulate the pilots. It's going to be tested in 2 industries. So I think the same dairy than the ASTEP, and a fish processing industry in Norway, right? Norway.
And what about the TRL?
I don't remember. Do you remember the TRL?
It's going to verify.
Okay, so pretty.
This
Relax.
is,
Yes. And what about
Research Innovation Action. So
Yeah.
it's aimed for.
And what about the temperature?
Up to 250, I think.
Okay.
So the fish industry is also using heat and not cold, or both?
No, it's producing heat because it's a fish processing. Like, they produce food for us, for people, but also pellets for feeding animals, and also omega-3 content and stuff like that. So it's not fish cooking and that's it, but different products.
All right.
well then, is there anybody wants to add anything to this discussion? Or any? Well then, I guess we can close it. Thanks everyone.
Thank you very much for the very fruitful discussion.
For leading. It's much nicer than just listening after such a day. And yeah, let's meet again with a coffee because it's coffee break.
And then after there's the friendship presentation.
Yes.
Which workshop?
What is it called? I don't know. It's
Or solar.
It's covered.
yeah, exactly. It's called.
So if you want to know the technical
Registration on the online, and they have given us the link for the videos for the friendship project. So for the online people, you have it on the chat, and I will project it now in case anyone wants to.
And it's also, if you, in the leaflet, there's the QR code. With this video.
Okay. Or one of those.
Yeah.
Thank you.
And that's it.
Thank you very much. Thank you.
Thank you for organizing.
Thank you.